we're ready. Let me just check my sound. Okay, right, good day everybody, and once again we are back together. I see we've got quite a number of people that have joined us on this live. Please let me know if I am audible. I'm able to see your comments namhlanje. Please let me know if I am perfectly audible. Alright, so on this live we are going to be looking at the paper from Limpopo. Okay, so I'll be picking a couple of questions. The first one, I'll go through just a little bit of some analytical geometry, and then secondly, I will also go through just a bit of trig. What I want to focus myself on a lot is trig graphs, okay, because I know that a lot of you tend to struggle with that. So I will cover that as well. And then we will conclude with a bit of Euclidean geometry. In particular, I wanted us to look at the proportionality theorems, right? So please let me know if you can hear me. I'm ready to start the lesson if you are ready. I see even my visuals are a little bit better today, and I hope that we will be able to be together. Now, before I get started, please remember that you can be part of our memberships, right? That's going live already. Okay, so our memberships actually start from as little as, I think it's 20 rands, right? So you can be a member on this channel, and what that gives you is added benefits. You get to know about bursary information, you get to know about the events that we are curating, but also now and then I will go twice in a week. I go live only for members, right? And we're able to do that together. Now, before I get started, guys, I just wanted to make sure. I see Blessing says we can't hear you very well. All right. Let me just check here with my team. Just give me a second, guys. Gracious? Yeah.
Please just switch off the lights and then connect your mic. Your mic is not connected.
Oh, my mic is not connected. Okay. All right. Awesome.
Yes.
Sure.
And then please switch off the lights.
Okay. Should I kill it all together?
Kill it all together. We can see you.
Sure.
Sure.
All right. Apologies, guys. Okay. All right. I just want to check again, guys. Am I perfectly audible? Yes, I think that is much better. That is so much better. Okay, please let me know. Just give me a little bit of feedback so that I know if I am perfectly audible. Just give me a sharp. Okay, right. All right, I'm going to go straight into it. Right, so what I was saying is that please just remember that we are able to go live twice for our members. So please just go and check out our memberships, okay, and be a member. It helps, keep this channel going. I don't mind financial support, guys. So for those of you that are able to and can afford it, please just be a part of our members. It is very affordable. It starts from as little as 20 rands. Okay, Sanbonani, good afternoon. I hope that you guys are well and you will be joining us for the rest of this live. So what I am going to cover, Euclidean geometry, all right? So that will be the last thing that I do. I will be able to cover some trigonometry, but I will focus a lot on the trig graph. All right, and I will also focus on a little bit, maybe not as much, I will look at analytical geometry. So those are the three things that I'm going to be doing during the course of this live. I do apologize for the sound earlier on. It seems like our mic was not connected, but I hope that all of us are okay. Please give me feedback. Let me know if you guys are okay, and then I am going to start. Now, this coming week on Thursday, for those of you that will be writing physical science, okay, there are two things that are happening on Thursday. Number one, we will have our workshop that is taking place. For those of you that may want to join in, it's only for 200 rands. You get about 4 to 6 hours, depending on, how much we are able to cover, all right, of content in physical science. We are going to cover, all the topical issues, but you get to ask me questions that are, the questions that you really want to ask. Those workshops are not really meant to cover content per se, but I am able to cover questions, and I'm able to also give you advice on what will be taking place. All right, and then another thing is on Thursday again, I will go live just like I'm doing now. And please join us for that. All right, so if you're ready to learn, I am ready to teach. Okay, I see someone still says adjust your screen. Shares, if you are available, please let me know if I'm good. Just show me on the comment section, then I will be able to start. All right, now let's get right into it, guys. So I took the paper from Limpopo, the June paper from 2024. Please note that we have pinned it on our comment section, so you will be able to get hold of that paper in our Google Drive section. All right, so you will be able to get that for yourself. All right, now let's get into it. So the first thing that I wanted us to do is to look at analytical geometry. I do apologize profusely if you can't see very well. But I will try to annotate and talk about the question that I have here. So they say to us, in the diagram, the circle P with equation x minus 2, y plus 3 squared, right, is equal to 34, is drawn. The point A, which is 4 and 5, is a point on the tangent defined by. So they've given us an equation or an expression for our tangent there, right? So they said it is defined by, I see I'm getting another call again. Yeah.
Sorry about that. Google Meet, the students are waiting also.
What do you mean? Okay. Oh, guys, Aski's technology is really giving us a bit of an issue today. All right, sorry, I'm just going to call a member of my team just to check what is going on. Yeah, I don't know, the call dropped.
Maybe you need to join the Google Meet. The students are waiting.
Yeah, man. They didn't confirm what they are coming. Okay, all right, that's fine.
Okay, I'll just tell you to have them join the live, so it's less of a distraction.
Yeah, they'll rather join that. Okay.
Okay, sure.
All right, sure. Okay, right. I do apologize about that, guys. As I said, we're just having so many glitches today. All right, so what I'm going to do is, they said to us in the circle, sorry, I just want to try and admit my students that should be joining me. Okay, let's check. All right, good afternoon, guys. Yeah, I did not know if any of you had confirmed what you're coming, but nonetheless, please, if there are any questions, you're more than welcome to ask questions. All right, so I'm going to start. All right, so what I had said is that I'm going to actually start with, let me just do this quickly. Right, so I'm going to start with the question on analytical geometry. Right, hopefully we are now going to get going after some glitches. All right, I think we are good to go. Right, so analytical geometry, let's start with that. So they said to us in the diagram, we've got the circle, P with the equation x minus 2 all squared plus y plus 3 all squared, which is equal to 34 is drawn, right? They say the point, which is A, that's 4 and 5, is a point on the tangent which is defined by, so the tangent is defined to us by 5y equal to 3x plus 13. And they say B, which is A and B, right, is a point on the circumference where the tangent touches the circle. All right, now I'm gonna go right into it. Nah? Right, so in this case, I want you guys to please be mindful of the following. Whenever you are doing analytical geometry, please firstly just note, it still is geometry. So what does that mean? I still need to know the properties of Euclidean geometry and still need to know the properties of circle geometry. For instance, if I look at this, if I were to draw a line from the center and where it meets the point, the tangent at the point of tangency, right? What then do I know? I know that this will be perpendicular because of tan perpendicular to radius, okay? So in this case, then I know that still the laws or the principles of Euclidean geometry still apply on this section, right? Now, let's go into the questions. They say to us, determine the coordinates of P, right? And the value of the radius of the circle. So if you look at that, they had given us the equation of the circle, right? And remember, once I know the equation, it means that I know, in this case, especially if they give me in this format, right? I've got x minus 2, then it means, sorry, the x value of my center is 2. Note that it changes sign. And the y value for my center is -3, right? Also, it has changed sign. Now remember, in this case, it means that r squared is equal to 34, which means if I was looking for the radius, I am going to simply take the square root of 34, and that's going to give me my value for r. All right, now, they said to us, determine the coordinates of P, so we found the coordinates. That's 2 and -3. And it makes sense because that's in the fourth quadrant, right? So if it's in the fourth quadrant, in this case, my x value should be positive, my y value should be negative. So that makes sense. They said, and the value of the radius, so the radius, we said r squared is equal to 34. and so which means that r is equal to the square root of 34. I'm not going to try and solve that, right? But we just simply know that the value of r would be the square root of 34. I'm not going to simplify that. No? Right, so they say to us, write down the gradient of the radius PB in terms of A and B. Right. Now notice in this case, so which means the gradient rather should be y2 minus y1 over x2 minus x1. Now I want you to note in this case, what is my y2 value, right? You notice I'm going to take b as my y2 value. So let's say this is x2, y2. This is going to be x1 and y1. So that's going to be y2, which is b, minus a negative 3. So that's minus a negative 3 divided by x2, which is a, minus 2. So which means the gradient in terms of a and b of the line PB will be b plus 3 over a minus 2. That is the expression for the gradient of that line. Right, now let's go to the next portion of it. So they say to us, determine the gradient of the tangent of AB in terms of A and B, right? So I want you to note again in this case that if I were to take the gradient of the tangent, remember that the gradient of the tangent, if the two lines are perpendicular to each other, right? So remember that the tangent is perpendicular to the radius. So if they are perpendicular to each other, then it means that the product of their gradient, so if I take MBP multiplied by the gradient of the line BA, which is the tangent, okay, that's going to be equal to -1. But I want you to always keep in mind that whenever I'm looking for the gradient, right, of the other line which is perpendicular to the other, it will always be the inverse with a changed sign, okay? So if the one was positive, so the other one will be negative, but it will be the inverse. So which means the gradient of the tangent, okay, if the gradient of BP, the line BP, was b plus 3 divided by a minus 2, then the gradient of the tangent will be negative. So I'm changing the sign, right? And now I'm inverting the fraction. So that will be a minus 2 divided by b plus 3. Does this make sense to all of us, guys? All right, so that will be a, so I've inverted that so that when I multiply them, I get a product of -1. So please keep that in mind. No? Right, so they said I must express it in terms of A and B, and that is exactly what we did. Now, they say to us, hence or otherwise, show that the values of A are equal to -1 and that of B is equal to 2. All right, now how can I show that value? First of all, remember that you know what this value here is. I mean, you know the equation of the line AB. They had given it to us. Now let's try and express it in terms of just y, right? So let's make y the subject of the formula. So that means y. Okay, sorry guys, I'm just going to make my pen a little bit thicker. Right, I hope that's fine. So y is equal to, I'm going to divide everything by 5, right? So that we just have y. So that's divide by 5. What I do on the right, I do on the left. So that will be 3 over 5x plus 13 over 5. All right. So now I know that the gradient of the tangent, which is minus a plus 2. So I'm going to try and solve it over there. So that's minus a. So that's minus a minus 2 divided by b plus 3. This should be equal to the gradient of our tangent, which is 3 over 5. So this should give us 3 over 5. Now let's try and work it out such that we've got the subject of the formula, or we can make one of them the subject of the formula. So I've got minus a plus 2, which is equal to 3 over 5 times b plus 3. Okay? So if I put negative a there, plus 2, okay, that's still, okay, I'm just going to switch this guy off again. So this is going to be 3 over 5 multiplied by b, right? And this is plus 3 over 5 times b will give me 9 over 5, okay? So now I'm going to have minus a is equal to, that's going to be 3 over 5 multiplied by b. And if I take the 2 to the other side, that will be 9 over 5 minus 2. Let's do that quickly. So that's 9 over 5 minus, that's 9 over 5 minus 2. Okay, and that gives us negative 1 over 5. So that's negative 1 over 5. So which means if I wanted to isolate a, so a will be equal to negative 3 over 5b plus. So I'm multiplying everything by negative, and this will be plus 1 over 5. So let's call that equation 1 because we've got 2 variables. So now, where else can we actually get an equation? Remember, we still have the other equation, right? We still have the equation AB from BP, right? We know that from BP we had b plus 3 divided by a minus 2. So b plus 3 over a minus 2. But what is this equal to? Remember, this is going to be equal to, in this case, remember that we know the gradient. If the gradient of the line was 3 over 5, right, then what should be the gradient of, or rather, what should be the gradient of the other line? So the other line must be negative 5 over 3. Remember, we said that if the gradient in this case is 3 over 5, then it means the other line, which is perpendicular, you invert the gradient, right? And you change the sign. So which means that this value here, b plus 3 divided by a minus 2, will be equal to negative 5 over 3. Okay, right. Now please keep that in mind. And again, we can play around with the equation. And by the way, there was another way in which we could get those values, but I'll show you that again later. So I've got b plus 3, which is equal to negative 5 over 3, and I'm going to cross multiply times a minus 2. Right, and again, I've got b plus 3, which is negative 5 over 3, a plus negative 5 over 3 multiplied by negative 2, I'll have positive 10 over 3. All right, and now I can express, or I can find an expression for b, or if you want to, we can find an expression for a. So which means, in this case, I can say, well, b is equal to negative 5 over 3, right? So please keep in mind, where did we get the 5? Negative 5 over 3, right? From that gradient over there, right? So this is going to be negative 5 over 3. This is A, right? Plus 10 over 3. Please work that out for me. So that's 10 over 3. That's minus 3. And so that gives us 1 over 3. So this is plus 1 over 3. So this is the value for B, okay? And maybe if we wanted to make things a little bit easier, we could have multiplied by 3 there, but it doesn't really matter. So now what can we do? We can substitute. So this is equation 2, right? So what are we going to do? We're going to substitute the value of A, right, into that equation. And please, guys, I think for the sake of time, allow me not to do that. You can do the maths yourself, right? I've shown you how to go about that, right? You can substitute the value of B into the equation. For the sake of time, I'm not going to go all the way there. And you will work out the value of A as well as the value of B. What we do know is that ultimately our answers must give us A, which is negative 1, and B, which is negative 2, which is 2 rather. So what I'm going to do is I'm going to put those values right there so that we remember to use them. So that's going to be negative 1 and 2. So that's the value for A and B respectively. Okay, right. What you also could have done is you could have derived an equation for the line BP by realizing that the gradient of it will just simply be negative 3 over 5, and you've got one of the points there which is 2 and negative 3, and then find an intersection for the two sides, right? For the two lines, and where the two lines intersect, that is where we are going to find our equation, or rather that is where we are going to find the value of A and B. And sorry guys, I won't have the time to go through all of it, but we do know in this case how to go about that. So I'll just cut the algebra part. You will do that for yourself. Né? Now the next one, they say to us, calculate the length of AB. Right. So now this becomes easy because we can just use the formula for distance, right? So we're going to say AB is simply going to be the square root, okay, of x2 minus x1 squared plus y2 minus y1 all squared. And now what we're going to have is for AB, right, our x2, I'm going to take that 4 there. So that's 4 minus a negative 1. So that will end up being plus 1 squared. So 4 minus minus 1. So negative times a negative, gives us a positive. And for our y values, so that's 5 minus 2. Okay, all squared. And so what should be that value there? We are going to get, that's 5 squared plus 3 squared. So that's 25 plus 9. That should give us the square root of 34. Right, so that should give us the square root of 34. All right, I hope you guys are okay so far. All right. I see there's a question there from Marcus. He says, isn't it supposed to be b plus 3 divided by negative a minus 2? Okay, so please remember, when you looked at a, let me just show you quickly. When you looked at a, initially, we had a minus 2. So once you multiply it with a negative, it becomes negative a plus 2. Okay. Marcus, I hope that answers your question. Né? So please be very careful with with multiplication, particularly when you're multiplying a negative, because if you don't put it in brackets, then you oftentimes you forget to multiply the other terms, right? So please, that's one of the very common mistakes that we find in mathematics. Okay, so please just keep that in mind. All right, let's go to the next part. They said leave your answer in third form, so that means I'm going to leave it as the square root of 34. And of course, because we're dealing with length, you can say units. All right, now they say to us a second tangent is drawn from A to touch the circle at C, which is D and 0. All right. So, which means this tangent is going to touch the circle. Sorry, they said at D and 0. Sorry about that. So that means it's going to touch here. When we've got an x value and the y value is 0. So they say we've got another tangent, right? And that tangent touches the circle at C, at D and 0. So meaning our tangent would go something like this, okay? Let me just draw it nicer so that you can tell it's a tangent. All right, there we go. So there's our tangent in that case. So they are probably going to ask us, I thought as much, determine the equation, the value of D. Right. Now here's what I want you to note in this case, right? How would I be able to find the value of D? Remember, that lies on the circumference, right? So on the circumference of the circle, that is where the equation of the circle comes in. But what's happening at that circumference? This is where our y value is equal to 0. So what I'm going to do, it means that I'm finding, in this case, so on the circle x minus 4, all right, so that's x minus, okay, sorry, just the equation of the circle, that's x minus 2, y plus 3, x minus 2 squared, y plus 3 squared, this is equal to 34. But what's happening at that point C, right? This is where y is equal to 0. So which means let's find out what C is where y is equal to 0. So that's x minus 2 squared plus y is 0. So that's going to be 0 plus 3, right? Squared, and this is equal to 34. And please, let's try and find that quickly. So that's x minus 2 all squared. Remember, we've got 3 squared, which is 9. If I take it to the other side, that's going to be 34 minus the 9 that I found from this 3 squared. Okay. All right. So I've got x minus 2 all squared, right? And, 34 minus 9. In that case, so I've got 34 minus 9, right? Which I've got as 25 over there. Now please remember, this is x minus 2 all squared, right? Rather, I'm trying to say we're finding the square root on either side. But remember, when you find the square root, you say plus or minus. So this is going to be x minus 2, which is equal to plus or minus 5. Okay, so we're going to have x is equal to, right? Or rather, let's say x minus 2 is equal to 5, or x minus 2 is equal to negative 5. So we've got one of the values. It will be x is equal to 7, or it will be x is equal to negative 5 plus 2. That will give me negative 3. Right, so which means that tangent could have been at 2 places, right? It could have been on this side, right? But it also could have been on this side. So that side is 7 and 0. So we've got 7 and 0 here. And you've got another side over here. My eraser sometimes gives me issues. So we've got another side here, which is going to be minus 3 and 0. Okay, right, so those are the two values Now, in this case, they didn't even give us a restriction. They say a second tangent is drawn such that it touches the circle at D, and 0 determine the value of D. Now, the thing about it is that the examiner here, because they wanted one value, they should give us some kind of an indication which value they wanted. Somehow, they could have said D is greater than 0. Or they can say, something that will kind of give us an indication so that we can eliminate one of the answers, okay? But because they didn't, I'm going to actually accept both answers. Now they say to us, prove that BPC. Now let's do that quickly. So BPC, right? So if we drew a line over there, they said prove that BPC is actually equal to 90. So, which means they are saying to us, we need to prove that this angle over here is equal to 90. Well, that's very simple. Remember, we already have found the gradient of this line BP. We said the gradient of the line BP is -5/3, right? Remember, we inverted the gradient, right? And we changed the sign from that gradient that we've got for the other tangent. Now let's find the gradient of the line PC, okay? So gradient of PC, if we find that the gradient is the inverse again, then we know that, so that's y2 minus y1 divided by x2 minus x1. And so in this case, we've got 0, y2, okay, 0, minus y1, that's -3, divided by x2, which is 7, minus x1, which is 2. And what do you notice? We get 3/5. There it is, guys. So which means when I take the gradient of BP, right, this line over here, multiplied by the gradient of PC, right? Remember, that's 3/5, okay, multiplied by -5/3. That gives us -1. And remember, when we take the product of their gradients and we find that it is equal to -1, we know in that case that we are going to have the lines parallel. So I can therefore conclude and say, therefore, it means that BPC is equal to 90 degrees. Okay, I hope that's clear, guys. I didn't think that this question was going to take us this long. And yeah, let's go to the last part of it. They say if AB intersects the y-axis, right? So where's AB? Right, I'm going to try and remove all the other stuff there so that it's not confusing. Okay, so we found, right. So remember, the line AB is square root of 34. We've calculated that, né? That's square root of 34. So they say to us, if the line AB intersects the y-axis at D, okay? So intersects the y-axis at D, right? They are saying to us, and CP produced intersects the y-axis at E, right? So let's see. CP produced, CP produced, meaning if we extend this line, it intersects the y-axis at C, right? And now what are they looking for? Calculate the length of DE. So they are saying, if this is D, right? And I want you guys to see it. If this point here is D, and this point here is E. They want how long the line DE is. Now remember, we already have an equation for the line AD, right? That was y is equal to 3 over 5x, right, from this equation here, plus 13 over 5. Now remember that every time I take this, what is it? What does it represent? That represents the y-axis. So which means the value here, so x is equal to 0 and y is 13 over 5. Now I need to find out what would be the y-intercept for that line CP over there, right? So I'm going to say, but I know the gradient is exactly the same. We had calculated the gradient. We found it to be 3 over 5. So it has the y, the gradient. Y is equal to 3 over 5. You remember when we used it there, right? So the gradient is 3 over 5 x plus c. Now let's find out what is the value of the y-intercept. So the y-intercept for this guy, we're going to substitute a point that the line PC passes through, which is P, which is -2 and or 2 and -3, or we can even take 7 and 0, right? Which is the other point that was C. So we're saying when y is 0, x is equal to 7, what's our C value? So we're going to take 7 times 3 over 5. So this is going to be 21 over 5 plus C. And so that means C is equal to -21 over 5. Now note, guys, what this simply means is that when I go to point E, it means it's where x is equal to 0 and y is equal to -21 over 5. Now note that DE is a vertical line, right? So as it is a vertical line, it means that if I want the distance DE, I'm simply going to take the difference of the y values. So the line DE will be equal to 13 over 5 minus, so 13 over 5 minus a -21 over 5. All right? So please let's find that out quickly. So that's 13 over 5, negative and negative. So that's going to be plus 21 over 5. Okay, right. I'm getting a value 6.5 over there. Sorry, 6.8 rather. 6.8 units. Okay, so please work it out, right? So that means that the distance DE will be actually 6.8 units. Phew, guys, I didn't think this thing would take us such a long time. But so what I want you guys to appreciate is that when you are doing analytical geometry, right? Please consider it and remember that it is a part of geometry. And so you do need to know the relationships between all your geometric, the axioms, right, that we use, which are your theorems, in fact, that are in relation to Euclidean geometry. Okay, let me just check quickly if there are any questions. The gradient of BP is not 5 over 3. Please, I'm going to ask you guys, because I've given you this question paper, please download it for yourself. And then what you're going to do is please just go and work it out for yourself. Né? All right, I've given you a guideline on how to tackle the question, and then you can verify all the answers for yourself. Okay, so mine was just to try and guide you. All right, so if it is that maybe somewhere I made a mistake, please just forgive me for that, but you know what to do in essence, right? Now, let's go on to the next part, guys. And I did say to you, oh, goodness, I want us to look at trig graphs. Usually when I find people and they will always tell me, good day, we're having problems with trig graphs and so on. So there are two scenarios. You will either be asked to interpret a trig graph, or you will be asked to draw a trig graph. So either they'll give it to you, but either way, even if you have to draw it, they will still ask you to interpret it. Né? Right, now I want us to go through this very first question. This is question 6. They say to us, let me do this. It's okay. It's okay. I'll try and erase the stuff that I've written here so that I've got a little bit more space to work from. Okay. Right, I'm hoping that this is helpful, guys. Blessing says that 4.6, the end didn't make sense. Okay, I'll try to emphasize that again, Blessing. So remember, I said that is a vertical line. Please do watch this again so that you will be able to see what I actually meant. So they wanted the distance between the two x values from the tangent and the other one from the line CP. So they wanted the y-intercepts. And so the distance between that line will be the y-intercepts, the difference between the two y-intercepts. Okay, please go and watch it again and hopefully it will make a bit more sense. Okay, right, now let's go through the trig graph. As I said to you, this section, guys, really it is not that difficult. All right, let me just show you quickly. So they say to us, we've got f of x, which is cos of x minus 30, and g of x, which is sine of x. And this is x is an element of minus 90 to 90. Now, what you're going to do, guys, notice that firstly, for this graph here, that they've given you, f of x, they have shifted the cos graph by 30 degrees. So what you normally do is you are now going to use 30 degrees as your steps. Okay, right. I left my water somewhere. I need to go and fetch my water. Otherwise, phew. I was cycling today, so I don't know what I was doing. And now I am really, really thirsty. Okay, right. So which means that's going to be my step. So we are drawing graphs between minus 90 and 90. Now they say to us, if x is an element of minus 90 to 90, solve the equation f of x is equal to g of x. Let's do that quickly, guys. So f of x equal to g of x, it means that I'm going to take cos of x minus 30 is equal to sine of x. All right. Now notice I've got cos and sine on either side. Né? Because it's different angles, I can't just divide by sine, right? So what I'll need to do is convert one of them to look like the other. So either I'll have cos and cos, or I'll have sine and sine. I prefer cos because it's easier to solve. So I'll have cos of x minus 30 is equal to, now remember, I'm going to use my co-ratios. So the cos of 90 minus x is equal to sine of x, or the sine of 90 minus anything is equal to cos, right? So in this case, I want to have cos and cos on the other, on either side, right? And so now that I've got the same trig ratio on either side, then I can say it means that x minus 30 is equal to, now guys, I am mindful, all of us have got different methods that we use, right, in this section. Some of you prefer the reference angle method. Mine just simply says, every time I'm solving for cos, I am just simply going to say plus or minus the answer. Why is that? Because when you draw the cos graph, let's say this is what the cos graph looks like, right? Anytime I'm looking for a solution, let's say cos, where the cos graph is equal to 0.5, it's over there. But can you see it's also on the negative side? So when you solve for cos, it's always plus or minus. Okay? You get the same solution. So that's why I will always say plus or minus. So now I'm going to say x minus 30 is equal to positive 90 minus x, or, sorry, this is plus k 360, where k is an element of integers. The other solution is that x minus 30 is equal to, now again, minus 90 minus x, okay, plus k 360. Right, so that's going to give us, if I take the x to the other side, I end up with 2x is equal to, if I take the 30 to the other side, it becomes positive, so that becomes 120 plus k 360, right? And if I divide both sides by 2, what do I end up with? X is equal to 60 plus k 180. Now remember, they have given us an interval, so we are going to have to find a specific value for x in that case. And then, what else do we have? We've got x minus 30 is equal to minus 90, minus 90 plus x. In this case, the x is cancelled, so in that case it means there's no solution on this side. Okay, so there's no solution over here. Right, now we need to find out what values are applicable between the interval minus 90 and 90 in this case. All right, so please stay with me now. So which means I'm going to take k is equal to, okay, let's take the first one. K is equal to 0. So that means that x is equal to 60 plus 0 times 180, which is 60, right? That definitely is within our interval, our given interval. If I take k is equal to 1, you'll see that it now becomes outside of the interval, right? Because I'll have x is equal to 60 plus 1 multiplied by 180, which is going to be outside of our interval. If I take negative 1, it will be x is equals to 60 plus negative 1 plus 180, and you'll see that minus 180 plus 60 will give us minus 120. That's still outside of the interval. So which means we only have one solution where those two will intersect, and that is at x is equal to 60. Right, now let's go to the next part, where they say to us, draw the graph of f of x and g of x on the same set of axes, right? Okay, right, now let's do this. So you guys have got very powerful calculators, né? That are able to do this. So you will go onto your calculator and go to mode. I'll show you on mine. It's not exactly the same as the brand that you are using. So usually you go onto mode and you go onto table, right? Whatever table is to you. Right, so the first graph that I have, remember, my first graph is cos, so I'm going to say cos of x minus, so it's alpha x minus 30, minus 30. Right, and then you press equal to, so that you can get g of x. G of x is sine of x, you're going to put that. Sine of x, I already have that there. This is from negative 90, right? Say equal to, until 90, and my steps are 30, right? And what it will give you, it will give you a table wherein you are now able to draw that graph. So let's do that. So I'm going to draw, of course, in your case, you probably will be given a set of axes where you can actually draw the graph. So I'm going to say this is 30, 60, and 90, minus 30, minus 60, and minus 90. Okay? Now notice here, let's start with the first graph, the graph of f of x. So this is going to be 1 over 2 and 1. Okay, so that's y. And this is going to be x. Please don't forget to label your x's. Nah? Right. So my cos graph starts at minus 1 over 2. Minus 1 over 2. And that's negative 1. So negative 1 over 2, it's over there at negative 90. At 60, my graph is 0. At negative 30, my graph is a half. At 0, my graph is root 3 over 2. So this is somewhere here, 0.866. At 30, my graph is equal to 1. All right. It's not going to be very accurate. At 60, 0.866, and at 90 it is equal to a half. So my graph looks something like this. Okay, right, so there's my first graph. And then for my second graph, I'm going to draw it in a different color if you don't mind. Okay, right, so they say to me at negative 90 my graph is negative 1. Okay, and negative root 3 over 2 at negative 60. Okay, at negative 30 my graph is negative a half. So there it is there. At 0 my graph is 0. At 30, my graph is a half. At 60, my graph is root 3 over 2. Okay, there it is there. 3 over 2. And then at 90, my graph is equal to 1. Right. So, how is my graph going to look like? Okay, right. I missed it here just a bit. You remember where we found that the two graphs intersected was at x is equal to 60. Of course, my graph is not very accurate so it means there you see it. They intersect at that point, and that point is where x is equal to 60. So it is at that point where they intersect. All right, now let's solve for the rest of it. I hope that you guys are still with me. And I hope this is going to be very, very helpful. Right, now they are asking us, hence use the graphs to answer the following questions. They say write down the range of f. Now remember, what is the range? The minimum and the maximum value. Nah? So I forgot to label my graph. So this is g of x in red, and this is f of x in blue. Okay. Right. So what is the range for f? So my graph starts at minus a half. That's the minimum value, the blue graph. And where is the maximum value? My maximum value is at 1. So the range would be y is an element of negative a half till 1. Okay. So that's the range of our graph of f. Okay? If we wanted the range of the red graph, that definitely is between negative 1 and 1, right? Because that's the minimum and the maximum value between that interval. Right. And then the next one, they say for which values of x will f of x decrease if x increases? Now remember, every time they ask us these questions, we are always moving towards the right, okay? We're always imagining that we are going to the right-hand side of the graph. So where is our graph of f increasing? Where is it going up as we move towards the right? Where are we going uphill, right? So for the graph of f, where are we going uphill? We are going uphill from negative 90, right, all the way up until 30, right? That is for the graph of f. Oh, sorry, they said for which values will the graph decrease? So that means we are going downhill. Sorry about that. We are going downhill. Where is the graph going downhill? We are going downhill for the blue graph. We start from 30 and we are going to 90. Hey, you know, when I was busy by skiing today with my cycling, I was looking for those downhills, guys. Yo, I'll tell you. Right, so where is it going downhill? From 30 till 90. So we can say where x is an element of 30. Now remember, 30 would be excluded because it's not going downhill. It's at its maximum there, right? All the way up until 90. We are going to include 90 because it is still going downhill at that point, right? In that case, we know that it is still going down. So that is going to be from x is an element. And by the way, if you prefer to write it in inequality form, that means that x is greater than 30, okay, less than or equal to 90. That's what it looks like in inequality form. Right, I hope, guys, you are still okay. All right, I see you guys are interacting with each other quite a lot. Are there any questions from those of you that are on my online space? I don't even know if okay. Are you guys still okay? All right. I'm not sure why you guys are not able to talk. Or maybe I switched off the speaker. I'll just take a little bit of a commercial break right now to go and fetch water just after this question. Right, I'm sure now you can stretch your body quite a bit. Okay, and then they say to us in the next question, if x is an element of negative 90 to 0, so what are they saying? We must focus only on the left-hand side. They say for which values of x will f of x multiplied by g of x be greater than 0? Now, guys, for these questions, please, I want you to listen to me very carefully. So to answer these questions, remember, when we say greater than 0, what does it mean? It means that our answer has to be positive. So when is it that when I multiply two things, I get a positive value? Well, when my signs are the same. So it means f of x is positive times g of x. So both f of x and g of x have to be simultaneously positive. Where is that? Where is that happening? Right? So remember, we are looking at the left-hand side of the graph, meaning we are looking on this side. Where are they simultaneously positive? Well, that's not there. Because look at this. When this one becomes positive, right? The thing is, g of x is consistently negative, right? Between that interval. So they are never both positive within negative 90 and 0. But remember, we also need to look at when they are both negative. Remember, negative times a negative still gives me a positive, right? So, where are they simultaneously negative? Right. Where are both f and g negative? Right. So, in this case, when I look at it, this is going to be, I look at this guy, consistently negative, but this one is negative only between negative 90 and 60. So where are they both negative at the same time, right? That's between 90 and 60. So what are we going to say? Right, let's remove this so that it doesn't confuse you. Right, so where are they simultaneously negative? It means this is where x is an element of negative 90. I'm going to include that because they are negative at that point, but only up until x is equal to negative 60, right? That I'm going to include as well. So negative 90 to negative 60, I'm including it because they said greater or equal to. Okay, so please keep that in mind. And finally, guys, I'm sure some of you are thinking, sure, thank you, Malum, waze waqeda on this section. Right, so, all right, I'm just trying to get rid of the stuff here. Let's go for it. All right, they say write down the value of x where g of x is greater than f of x. Right, now let's check. Where is g of x? Where is the graph of g above the graph of f? Well, that never happens until we get to 60, right? So when we got to 60 over there, what happened, right? Oops, I made an issue there. Right, when we got to 60, this is where f of x is above, the red graph is above the blue graph. So that means in this case, where is f of x, g of x greater than, or where is f of x, g of x greater than f of x? That's between 60 and 90. So we're going to say x is an element of 60. Now 60 would not be excluded, would be excluded because remember they are equal at 60, right? And we only want where it is greater than. And 90, but 90 would be included because at 90 the graph of g is still greater than the graph of f. So I'm going to include that graph. Guys, I hope that makes sense. Please watch this again. And if you can, do watch all the graphs, the questions that I've done on graphs, trig graphs. Né? It is not a bad section, particularly when you know what to do with your calculator, when you need to draw the graph. But the interpretation thereof is something that is really quite logical if it is. Homolimo, you've got tears. I wonder why. Yes. Why are you crying? Okay. Unati Joy says, the Lord is my shepherd. He truly, I hope he is, right? Yeah, I hope he is. And ngizwile but you guys didn't go to church today. I'm watching you. All right. Now, can I just take a quick break, guys? Not a long break. I just want to go and fetch water. I want to continue. So what we're going to do now is I am going to just quickly jump into the proportionality theorem. I think for the sake of our time, there's still some more that I wanted to do, but I know that proportionality theorem sometimes becomes a bit of an issue, and I'll try to see if the guys that are online can still hear me. Yeah, I think they can, but it's just that I turned down the volume. Okay, right, just give me a second, guys. All right, those of you that are online, can you hear me? All right, sorry man, I had switched off the speaker, and that's why I couldn't hear you as you were responding. Probably you were responding, nah? All right. Okay, there's my water break. Thanks to YouTube, I've got this wonderful, nice little water bottle. All right, and I hope that you won't mind. In the process of this live, I'll just be drinking water. All right. Let me just check if there are any questions. Let me put this there. Khumulimo says he has been thirsty. Yes, I have been. I've been talking for so long. All right. I hope that you guys are still with us. All right. Now, let me do this, guys. I tried to put this question. Goodness. Yes, there's so much that I wanted to do with you guys, né? But let's see how far we can go. Right, now let's go to this question, which I really thought was a very interesting question. Now, guys, can I just first advise when it comes to proportionality theorem? It's not a standalone section. Maybe sometimes it is when they give us those triangles, that are those diagrams where we've got triangles with parallel lines and so on. But usually when it comes to the proportionality theorem, it still is a part of the circle geometry, Euclidean geometry. So you won't be effectively able to do a proportionality theorem if you don't know Euclidean geometry. So please just intertwine the two. Get used to that. Okay, right. So let's quickly do that. They say to us in the diagram, we've got PQ, which is a tangent to the circle at Q. All right, so there's PQ. Okay, so as soon as we've got tangents, you remember, we know we are going to look for the 10-chord theorem. We know we are going to look for tangent perpendicular to radius. If we've got two tangents, then we know that are meeting at a common point, then we know that those are equal, right? They say to us, sorry, my drawing, it's not because of you, but my drawing is a little bit skew. I do apologize about that. It's actually the paper that I'm working from. So please, if it looks a bit skew, I do apologize profusely about that. Right, now they say to us, T, R, and A are points in the circumference of the circle, right? And S is a point outside the circle. All right, and they say RT meets the tangent at P. So they are just giving us all the information that is in relation to this diagram, right? And they say TAS and RBS are straight lines. All right, that's important. Now they tell us that PT, this line here, is 4 units. Okay, so that's 4 units, and TR is 5 units. So that guy is 5 units. Right, and again they tell us that PS is parallel to AB. All right, there it is. Right, those two lines are parallel. Right, now they say if S1 is equal to X, name with reasons 2 other angles equal to X. Now, guys, I want you to note in this case, I know sometimes when we go through Euclidean geometry, we try to work on the diagram as much until we confuse ourselves. Be very strategic about that, right? So they've told me already that we've got S1, which is equal to X. So I'm going to go there and say, well, if S1 is equal to X, which other angles are equal to X? Now have a look at this. Remember, we've got those parallel lines there. So can you see? We've got alternating angles. So what does that mean? It means A1 is equal to X. Right? So we've got A1 that is equal to X. But which other angle would be equal to X? Now remember, we also have they told us that we've got lines that touch the circumference, right? So in this case, A1 is equal to R1. What is that? That's the exterior angle of a cyclic quad. Remember that the exterior angle of a cyclic quad is equal to the opposite interior angle. So that means A1 should be equal to R1. So those are the two angles that are equal. So let's write that down. So we're going to say, firstly, S1, Okay, so we're going to, why is this thing giving us issues? So we're going to say S1, angle S1 is equal to angle A1, and I'm going to say alternating angles. Now please note, if I hadn't specified that my lines are parallel, I need to do so. So PS parallel to AB. Or you could have first outlined that PS is parallel to AB given, right? And therefore it means that S1 is equal to A1 alternating angles. Right, let's go to the next one. We said A1, which is equal to X, right? And we said A1 is equal to R1, which is equal to X. But why are they equal? Because we've got exterior angles of a cyclic quad. Okay, right, we've got a cyclic quad. Now, for those of you who may not have been able to see that cyclic quad, I'm talking about cyclic quad. Let me just try to highlight it there. This cyclic quad over here. Note that all of those points touch the circumference of the circle, right? So I hope you can see that cyclic quad. So it's this cyclic quad over here. Right. Want to remove those lines. All right. Now, they say to us, prove that triangle PQT. PQT is this guy over here. I hope that's visible. Yeah, there we go. Is similar to triangle PQR. So that big triangle over there, PQR. Now, whenever you need to prove similarity, guys, all you need are two angles that are equal. Once you can get two equal angles, the third one automatically becomes equal. The third set of angles becomes automatically equal because of third angle on a triangle, right? Now think about it. If the one is 40, the one is 40, the other one is 30, the other one is 30, then automatically, by virtue of angles on a triangle, the other one would be 110, right? So that you get 180. I hope that makes sense, right? So you need to prove only two angles. The third one automatically becomes equal because of third angle of a triangle. Right, now let's do that. So firstly, P1 is common on both triangles, right? P1 is the common it's the common angle. So you can say, so that was 10.1, 10.2. So we said P1 is common, right? And then, which other angles are equal? There we've got a 10-chord theorem, right? Q1, right? There's the tangent, the angle between the tangent and the chord is equal to the angle on the opposite side of that chord. So Q1 is equal to R2. That's because of 10 chord. That's the 10 chord theorem. All right. And then now Do you see that we've been able to prove two angles equal, right? So therefore it means the third one automatically becomes equal. So which means, which one is now left? It's T1 on the smaller triangle, all right? It's T1. And again, guys, I'm still asking you, please, once I'm done, have a look at these questions again. So T1 is equal to that entire angle Q1 and RQ. So I'm going to say PTQ. So therefore, PTQ, angle PTQ, is equal to angle PQR. And in this case, we say that this is, okay, the third angle on or of a triangle. Okay, so third angle of a triangle. Now, therefore, we've now proven three angles to be equal. And so in that case, it means, therefore, triangle PQT, I'm not going to waste my time on this one, is similar to angles PRQ. Now remember, guys, whenever you place similarities, once you order the angles, the similarity must be in order of the vertices, the angles that are actually equal. So if angle P is equal to angle Q, then if I start with P, then in the other one I must start with Q. In this one you can see angle P is equal to angle P, angle Q must be equal to angle R, angle T must be equal to angle Q. So we are going to come back to this probably in this case, and I'm showing you this. So whenever I have proven similarity, the proportionality theorem says if my angles are similar, if my triangles are similar, then their sides are proportional. So I'm going to take PQ, and I don't know if I'm still going to use this, over PR is equal to PT over PQ, which is equal to PT, what did I do? QT rather. QT over RQ. All right. So I want you guys to notice that, so this would be the proportionality theorem, but I'm going ahead of myself. I'm just showing you how you would apply that if you had a proportionality. Right, now quickly, let's go to the questions. They say calculate the length of PQ. Oops, I just erased what I had done here. There we go. Right, so to answer that question, they are leading me on. They are saying to me, use what you've just proven, right? So I'm going to use the proportionality theorem. PQ squared, what am I looking for? I'm looking for the size of PQ, right? But what am I given? I was given PT as well as TR, ne? Right. So there's PQ, there's PT, PR I can find. So which means PQ squared, right? Notice what am I going to do? I'm taking those two fractions and I'm going to cross multiply. So PQ multiplied by PQ, man, this guy. So PQ multiplied by PQ is PQ squared. PR multiplied by PT. Now because we're looking for a value, let's see. Can we find PR? PR would be 4 plus that 5. So PR is that entire side there. So that's going to be PT plus TR, which is 9. Okay. Multiplied by PT, but we know that PT was given to us as 4. So that's 9 multiplied by 4. All right. So this is going to be to give us PQ squared, but they wanted us to get PQ. So in this case, that's the square root of 9 multiplied by the square root of 4. So that will simply be 3 multiplied by 2. I hope we are all okay, guys. I hope we are clear. I thought Euclidean was easy. Hey, it is, if you know what you are doing. Nah? All right, if you know what you are doing. Now, let's go to the next one. So we found PQ. You can work that out for yourself. So for 10.4, right? Still using that proportionality theorem. Now they want us to prove that triangle PTS is similar to triangle PSR. Now let's work on it. So PTS is this triangle over here, right? They want us to prove that it is similar rather to triangle PSR, the big triangle over there. Right. So once again, guys, how are we going to do this? Firstly, do you remember that we've already proven that S1 and R1 are equal, right? Because they are both equal to X. That's already proven, right? And then we also know that angle P2 is common between the two triangles. So I'm going to start there. P2, angle P2 is common. Some of you prefer writing P2 is equal to P2 and then you write the reason common. That's really up to you. And then we said angle S1 is equal to R1. Right? That's proven because they are both equal to X. All right? And then, therefore, remember I said to you, all I need is to prove 2 of them equal. The third one automatically becomes equal by virtue of the third angle of a triangle. So then the last one would be equal to, that's T2, right? That would be equal to the entire angle there, S1 and 2. So T2 is equal to S1 plus S2. And that's because of the third angle of a triangle. All right, so therefore, what does it mean? Right, it means that we've got triangle PTS similar to triangle PSR. All right? Oh, by the way, sorry, I forgot even in the previous one. What's the angle? What's the reason for similarity? That's angle, angle, angle. Even there, when I had proven similarity, right? Some of you prefer writing the angles as I did, or you can say A to show that it's angle, angle, angle. Please don't forget that part. Né? And when you're using the proportionality theorem, always don't forget to say that's because of the proportionality theorem. All right, and finally, guys, we are right at the end. It's 19:30. I've gone and I've given you guys a bonus here, 30 minutes. Né? Please don't forget your favorite uncle. Yes, someday you must say, "Hey, that uncle saved my life." All right, so they said prove that PQ is equal to PS. Now, let's do this. So when I look at this, I've got PT over, all right, let me do this. So that's PT over PS is equal to PS over PR which is equal to TS, so it's this guy, TS over SR. All right, so I am looking for PS, so I'm going to take this guy as well as that guy. I'm going to say, well, PS squared. Remember, I cross multiply. PS squared, that's equal to PT multiplied by PR. Have we not seen this before? Right? So remember, PT was this 4 units over here times PR, which is that 9 units. Can you see? That's 4 times, sorry, that 9 units. Or you can even recognize it, but hey, we've seen this before, right? PS squared, PT times PR, but we also have PQ squared equals to PT times PR. So this means that PS squared is equals to PR, but you can also find the value thereof, so which means that this is going to be the square root of 4 multiplied by 9, and in this case that means that's 2 times 3, which is 6 units, okay? And so because they are both 6 units, with this guy here, PQ is 6 units, PS is 6 units, so PS is equal to PQ because they are both 6 units. Right, guys, I wish that I could have been able to spend a little bit more time with you, but I really do want to leave it here. Tati says, I'll buy you a stock suite one day. Hey, Tati, I will appreciate that stock suite. Maybe I'll be very old. You know, old people like sweets, ne? So I'll wait for that stock suites. Okay, all right. Tati says, thank you, sir. All right, you're most welcome, Tati. Uncle, please give a tip on how to attack the question in analytical geometry that asks us about the value of x for which a line can be a secant. Okay, right. Maybe let me in closure, ne? In closure. Takalani, I would have loved to do general solutions, but I think for the sake of our time, please do watch the videos that I've curated in the past on general solutions. There are definitely many of them. Yo, guys, even my voice now. Okay, there are many of them. Right, I think in conclusion, guys, you'll find that, and I've found that with a lot of people, they find Uti paper 2 is somewhat a little bit, they find paper 2 a little bit more challenging than paper 1. Ne? And honestly, that's only because paper 2 has a lot of diagrams that you need to work through, okay? So you have to get yourself into the rhythm or into the mood of paper 2, ne? So that you can be able to do well. So my advice for you for tomorrow, for those of you that will be writing, maybe those of you that will be writing in the near future, ne? Or even as we prepare for the final exams, my advice to you is have a strategy around how you are going to start paper 2, right? For me, my strategy would have been statistics is like your low-hanging fruit. You know that in that case, statistics is easy marks. Go for it first. But the second easier part would be your, in my opinion, analytical geometry. right? You know how to do, you know, things like distance. You know how to do things like the, you know, the gradient, you know, the center, and all of that. I mean, the midpoint rather, not the center. But the second part of analytical geometry, where it pertains to centers, and that's why I thought I should actually go through it with you. Isaac says, thanks, Mr. Mlungu. Mara, what's with that heart with the bandage? Okay, what's with that heart with the bandage, guys? All right. So my thinking is that you really want to know your Euclidean geometry so that you can be able to answer that part very well. You could see. I mean, we took 40 minutes just answering that first part. Okay, so please go through that first. For those of you, and I'm seeing the comments here, for people that are still struggling, guys, I wish you knew just how much I love you guys, and I want you to do well. I wish nothing but the best for you, okay? Sometimes the system in our school is not such that, you know, it's conducive for us to pass. And often enough, I say to you, you know, I say to people, it isn't such a bad thing for you to, you know, consider going through next year and upgrading, okay? If it is that, you know, that's an option that you want to take, okay? I've got students here that are doing extremely well, you know, after having spent an entire year with them. And they are here with me, they are upgrading, and, you know, they've gotten to unlock a potential that they didn't know existed at first. And so it's not a lure, guys. It's not me trying to deceive you. If it is that, I'd say give it your best shot. Go tomorrow, give it your best, okay? Don't be complacent. Prepare as best as you possibly can, right? But ultimately understand that what you don't know, you don't know. Start with what you know first, all right? Gradually move to the more challenging, the more, you know, the stuff that are still giving you a bit of an issue. You still have a bit of time between now and I'd say and 10 o'clock. Really, I think the maximum that you should push yourself to today should be 11 o'clock. And unless you're going to be watching this later, you know, and you would have slept before. But please don't go into the exam tomorrow without having taken good sound sleep. And as you've seen, I was drinking a lot of water, guys. Né? You know, drinking a lot of water and electrolytes will help your brain function at its peak. So please do so for tomorrow. For those of you that will be writing tomorrow, for those of you that will be writing another time, please do that as well. That's good practice to always be hydrated. But I want to wish you all of God's best, guys. I pray for you. I pray that you reach your potential. I pray that you reach not just your potential in terms of your study, but in terms of doing something that you love. I hope that you will continue to use the wisdom and the nuggets that I throw to you guys, the content that we curate for you guys. But I really, we really, and the team, you know, we try our best to give what is best and is of value to you. But I want to wish you all of God's best. We are going to meet again on Thursday. But for those of you who do want to be part of the other sessions, where I will be taking you guys through the whole of paper 1, you can do so. But I want to close it out with saying, Nyantanda, guys, I love you, I love you, I love you. And I really wish you all of God's best. And I'll see you again next time. For now, please allow me to go and rest. Ne? Okay, even my voice is asking for it. Sharp, sharp for now. Yabona, I even have a picture of the ocean just for you.